So today, there are going to be two sessions. The morning sessions will mainly focus on plant development in relation with the environment, temperature and rain mainly. The second session will look at the relationship between plant leaf area development and photosynthesis activity and its impact on fruit maturation. Also, for the purpose of this presentation, I kind of consider that a winemaker and a vineyard manager are kind of doing the same thing. It's just like making wine, but starting before the cellar. So sometimes you hear me speaking about the winemaker decision, meaning that it's a vineyard manager decision, but at the end of the day, it's all tied together. In order to give some context and link one presentation with one another, we sliced the vintage into 3 periods, with the thought in mind that the vintage 2014 started when the vine lost its leaf at the end of November 2013. And in order to really characterize the key stages of the development, we are first going to look during period 1 at how the conditions of rainfall and temperature preset the game before bud break. And we are going to look at carryover relationships. Then we will look on the green part, the period 2, when basically the explosion of leaf developing on the plant is really inducing a lot of metabolic changes in the plant, and we're going to detail that. And then during the session 2, we're going to track the fruit ripening pattern. So, period 1, what should we looking at? Well, during period 1, 2 things happen. The nitrate reductase is this enzyme that's really important into converting nitrogen into plant, assimilable nitrogen, and it's tightly dependent upon the amount of moisture in the soil, in the topsoil, and the temperature. Of course, nitrogen is key for the rubisco, the enzyme that is really deeply involved into the conversion of carbon dioxide into sugar, is majorly impacted by nitrogen content. So we'll try to bridge the gap between how much nitrogen is available in the ground and how much photosynthesis the plant is able to do. So for that matter, we are going to look at temperature during the period 1 and rainfall during the period 1. The first thing that is important to stress here is that if you look at temperature accumulation during November 1st until January 1st, you see that 2013, which is the beginning of 2014, is not standing alone so drastically different from other warm vintage. So it aligned pretty closely to 2013, 2012, and what also prepared 97. And you see, so things happen according to a pattern that is not completely unknown to us. However, if you look at January until April 1st, there you see a big footprint based on the speed at which temperature is accumulating, which will have, we know, carryover effect on speeding up bud break, speeding up bloom time, etc. So now that we have looked at the climatic demand, let's look at the water supply. Same thing, trying to slice onto 2 sub-periods, period 1. We see that from November 1st until February 1st, we all know there was a major drought, and this is where you see a large difference. So that means that from November up until February, we had 4 months during which soil moisture content in the topsoil was much lower than usual. Think nitrate reductase activity, think how my bacteria are going to convert nitrogen so it becomes plant assimilable. However, if we look at the total amount of water supplied through rainfall, you see that during the last 2 months of March and April, we kind of compensated a little bit for the drought. Bottom line, when the fruit and the plant, started to develop its leaf area, we can assume that there was not, right from the beginning, a very severe water deficit, which means that the leaf area could probably develop without any severe water deficit, at least during the first 30, 40 days of leaf area development. Okay, so at this point, just let's take one step back. If we look at rain and temperature effect over period 1, we saw that we had the warmest winter, and we know that this should have carryover impact on the phenology. Then, looking at water, we know that we had the driest 4 months during the winter, which should have impacted soil mineralization rate, and therefore plant nutrient absorption, with consequences in July. So in order to really nail down why the conditions pre-bud break are setting up the ground for plant water uptake, I decided to show this review from the literature. It was published in 2009, and here the author have looked at the impact of having a wet winter, looking at November 1st to April 1st. Here in blue, you had around 1,000 millimeters of water, and in green, we had only 250, so roughly 1 foot of water. And you see that just because we didn't have much water rain during the winter, there was less nitrogen in the ground, and when we look at the nitrogen content in the shoot, you see that there was a drop of 20%. So those data were obtained on a vineyard without any cover crop. And you see that your ability to photosynthesize, to do photosynthetic activity as a plant, is already going to be on a high or low level just as a carryover effect of the winter rain. If you have 2 different levels of photosynthetic activity, you may also expect 2 different levels of transpiration. Now, how is the situation looking like when we have a cover crop? Well, first of all, the cover crop, those are non-nitrogen fixing cover crop like barley or fescue. And you see that the trend is the same. So first of all, with cover crop, you have less nitrogen in the ground available for the plant. But also, you see that the impact of a wet winter over a dry winter is to reduce by at least 20% the amount of nitrogen fixed by the vineyard. Therefore, it will impact the ability for this vineyard to have an actively photosynthetic activity. So at this point, the take-home I'd like to make is that the lack of winter rain reduces nitrogen uptake. Cover crop is also reducing nitrogen uptake and soil organic mineralization, which may be sometimes counterintuitive. So at this point, the bud break has not even been seen. We are already ready to expect less nitrogen mobility, because even if you add nitrogen on the topsoil, with less winter rain, this nitrogen cannot percolate to meet deeper root absorption sites. Then we also know that the lack of water will reduce the nitrate reductase activity. So even if nitrogen was mobile, we will have less nitrogen available on the plant. And now we are just waiting to see how this will impact the photosynthetic activities. So 3 key ideas. The mineral content is going to be affected by the dry winter. And we can already see from those examples that we can expect at least 4 different levels of photosynthetic activity on a given vineyard. The phenology and the development will be strongly impacted by this warm period before bud break. Early bud break and effect of soil temperature on bloom time are very well known. And number 3, what are the other long-term effects of having had not enough winter rain on vine water stress profile and food composition? So this is why I was very pleased when Martin Mendes positively responded to our invitation to speak, because Martin had a very good anticipation of what we are experiencing now, since already in 2009 and 2010, he did a series of experiments by imposing drought pre-bud break on the plant. And I think his findings are key, because it's extremely useful to get ourselves better ready for 2014 and 2015. So I think it's good to have him explaining his result, to get inspired by his result and see that similarly to how nitrogen content can be impacted by lack of rainfall, there are even more carryover effect that goes onto wine composition. So without further ado, Martin, I'd like to invite you to speak.